So let f of x be equal to e to the power negative 3x minus 4, and g of x be equal to the mean of 1 over x plus 2. Well, where x is greater than negative 2, we understand that if x is 0, if there is 0 in the denominator, it becomes undefined. 1, 2, if there is negative inside the line, again it becomes undefined. That's why x has to be greater than negative 2, strictly non-zero down and non-negative, the whole thing. What does A request us to do? State the range of f. Oh, so we need to find the range of f. So if we are to attempt to sketch, we would say the horizontal asymptote here is the line y is equal to negative 4. And then the graph is going to be up because of the positive base. So when that happens, it means that the range is going to be from negative 4 to positive infinity. So this is open here. Okay, so maybe I'll write it. So it's going to be from negative 4 to positive infinity. Like that. That becomes our range. Alternatively, you know, you are used to solving for x, find the inverse. So you would say, okay, and let y be equal to e to the power negative 3x minus 4. And then solve for x. So you take for the other side and get e to the power minus 3x. Then apply ln. So apply ln this side and apply ln the other side. So that this guy can come out of the, just become negative 3x and divide by negative 3, divide by negative 3. And you understand that what you have now is negative 1 over 3 ln y plus 4 and we got x. And so you know the domain for ln is that this guy y plus 4 must be greater than 0. So y is greater than negative 4, which is what we have here. Well, solving this way is the same thing as saying when you reach here, then change to log. How do you change? You say log y plus 4 base e is equal to negative 3x. Then divide by negative 3, divide by negative 3. So we have x is equal to negative 1 over 3 log e y plus 4. And then you get the domain. So you say y plus 4 should be bigger than 0. That's how you solve that one there. So I'm saying this way, or this way, or the other way, you're giving the same range. If you want, you can even write this as a circuit notation. You use y such that y is greater than negative 4, but y is a real number. Or you say f such that f is greater than negative 4, but f is a real number. And then B is asking for f inverse. F inverse of x is equal to this thing we have found here. this thing. Because this is x, you say we go for the inverse. So you say it's -1/3 ln x plus 4. Because I've put x here, so I'll put x there inside. That's all. If you want, you even mention that where x is bigger than -4. The way they have mentioned for us here in this link. So you also mention to show that you understand what's going on. Then what next? Well, they're asking us to express f of g as a polynomial. This is the same thing as f of g of x, which they have written as fg of x. So, you know, in f, where there is x, you put g, but f is e -3, where there's x, you put g -4. And then what is g? G is ln 1/x+2, and then by -4 is standing alone. But you can take this guy to be the power. So we have e ln 1/x+2 to the power -3, and then -4. Well, we also have that property that if you have a to the power log of a base x, the whole thing drops down to x. The same way the log disappears, even in the exponent, it disappears as long as the bases are equal. So you know ln is base e, so the whole thing just drops to 1/x+2 to the power -3 -4. But this is 1/x+2 to the power -3 -4. Well, which is the same thing as x+3. I mean x+2 power 3 -4. Why have we said power 3 when it was negative down? Because we know that 1/a is the same thing as a to the power -1. And 1/a -1. Remember I said it will just be a, which is what we have here. And this is the polynomial in terms of x. There's not even no need of expanding. And that's how you answer C. Like that. Then to move, we go to question 14. For all x greater than 0 and y, solve the simultaneous equations. 2 log 2y is equal to 5 minus log 2x. We also have is equal to -3. So for all x greater than 0 and y greater than 0, solve the simultaneous equation. Well, the first thing you do here is use change. Go to the area that we are used. Change it to exponential. So how do we change this one to exponential? Well, it becomes x to the power -3 is equal to y. Like that. So we keep this one. Equation 1. Then we come to the other one. we take 2 in the power, so we have log 2y squared, and then take this side, becomes plus log 2x is equal to 5. What next? If there is plus here, then you bring together by multiplication. So we get xy squared is equal to 5. Then what next? You raise. So you have 2 to the power of 5 is equal to xy squared. Okay. What else do we know? We know that y is equal to x to the power negative 3. So where there is y, we put x to the power negative 3. So this becomes 2 to the power of 5 is equal to x 1 minus 3. Because we know if the bases are equal, we add the power. Then adding by subtraction, we get 2 to the power of 5 is equal to x negative 2. What does it become? This is 1 over x squared is equal to 2 power 5. So solving for x, we cross multiply, we have 1 is equal to 2 power 5 is 32, and then x squared. So divide by 32, divide by 32. So we get x squared is equal to 1 over 32, like that. And then from there, we have x is equal to plus or minus the square root of 1 over 32. Like that. Oh, but because of the negative, because of the x in the log, you know, you can't place a negative there. So the only solution that we're going to adopt here as x is the square root of 1 over 32. This number is simplifiable, but I can leave it just like that. So then what is y? Because we know y is equal to x to the power negative 3, which can be written as 1 over x power 3. And we know the value of x, so we substitute. So this becomes 1 over 32 to the power 3 over 2 as the value of y. So I say y is equal to, now if you want, you can even lift it and say plus 1 over 32 to the power negative 3. So we have found the values of y and x. So easy. And then next, we go to question 15. A population of bacteria initially has 90,000. So initial 90,000. And in 2 weeks, time 2 weeks, there will be 200,000 present bacteria. So present will be 200,000. Determine the exponential growth equation. The exponential growth equation, normally indicated as this, is given by A naught E K T, where A naught stands for initial, and then P of T stands for present, and then T for time, and then K is a constant that is normally found. So in this case, we've been given 200,000 as the present, this guy as time, and initial as A naught. So you substitute there, the equation, this one is going to be 200,000 is equal to A naught, which is 90,000, and then E to the power K, which is unknown, and T is 2 weeks, so we have 2T. Oh, then we know that if we divide by 90,000, these zeros will go, so we'll have a simple equation. E to the power 2T is actually equal to 20/9. And we are solving for, so put T there, supposed to be K. This is K. Yeah, and we are solving for K. So, you know, obviously, if we change this to exponential, to logs, it's going to be 2K is equal to ln. So because of this guy, so I'll use the base ln. Okay, it's going to be log E and then 20/9, implying that K is equal to, that becomes ln 20/9 divided by 2. That is the constant K. Okay, which if you want, you can rewrite as 1/2 ln 20/9. Now this can still be written as ln of the square root of 20/9, which is ln of root 20/3. I said if you want, you can leave it here, you can leave it there, you can leave it here, you can leave it here. All those are options. Then B, how far will it take for the population to grow from its initial population of 90,000 to a population of 150,000? So how far will it grow from the initial to the newly to be present? So this has been replaced. We're saying how far will it take for you to get 150,000 if the initial is still 90? So because of the still initial, how long will it take? So meaning the constant will be fixed. Remember the constant, we have found the ln of the root of 20/3, and then time. So we're looking for time here. We're looking for time here. So how do you look for time? Well, you know, this drops. This one will just remain with that constant there. So as you divide by 90 already, you know this will happen. You'll be dividing by 90,000. This cancels. So we have 15/9 is equal to the root of 20/3t. So meaning t is equal to 15/9 divided by root of 20/3, which is 15/3/9/20. So this is 1, this is 3, this is 1, this is 5. So we get 5/20. What is that? Since time here is measured in weeks, so we want to assume these are weeks. That is how long it will take. But you can divide, doesn't mean that when they say week, it has to be 1. But it can be 0.5 weeks. You know what calculate meaning, you know the days. 1 week is equal to 7 days. So there always be a translation. I mean a conversion, so you can always convert it.
Question, sir.
Hello.
Can I ask, sir?
Yes.
And do we use the same equation for an exponential growth or as for the exponential decay as well?
For the decay, the same equation, you just change. For the exponential growth, it's positive, but for the decay, you put a minus k there. It becomes, this is decay. For the growth,
All right.
okay, so for the growth, it's positive. This is growth. So that one question 16, what is going to be there is we initially have, so again, we are talking of initial. We have 2 kgs of radioactive element. In what time? And in 7250 years, there will be 1.5 present. Will be 1.5 kgs left. Determine the exponential decay equation. So you'd say, oh, it's now the decay. It's now the decay, so it will be A not E negative K2. The initial is 2. I mean, the initial is, the present is 1.5, and the initial is 2, and then E, and then minus. The time is 7,250 years K. And then you find K. So you divide by 2, divide by 2. You know that 3.5, I mean 1.5 is 3 over 2, so now we have 3 over 4. Is equal to E negative 7,250K. Then change this to ln, so you have ln this guy is equal to negative 7,250K. There's a question. That's a question. That does. Okay, so I take it that the computer pressed it. So you divide by negative 7,59250. So K is equal to the ln of 3 over 4 over the negative 7,250. This is the constant that responds to the decay. How long will it take for half of the element to decay? For which element? The initial. So how long will it take for half? So first get half. Say, oh, I have 2, but they're talking of half. So that would be 1. So you say 1 on the left is equal to so you have 1 on the left where there was 1.5, and so you still have the same initial, and then you have a new constant found, which is the K. So it is going to be minus K, which becomes positive when you multiply it with a K. So it becomes positive, and then you bring in the ln. Now, because you know that here there will be an issue of solving for the actual time. So you push this guy into the power. Anyway, to do we brought the other one. So check out this one. So we brought this guy, substituted in the power. In fact, this substitution, I need to check it. What was multiplication? So when you say KT, so let's recheck this one. When you say KT, this T does not sit here because it's, if we put it here, then we must have this whole thing like this. So since that's a constant, so we'd say that, okay, we want T to sit at the back of it. So we'll put T here. So that when you put it like that, then it will be treated as a coefficient. So it can raise in the power and not as a product. So it will be raised in the power. So we'll come back to this one. Notice that there's some normality. Okay. So we come back and say, okay, this is 15 over 9 is equal to E, then the root of 20 over 3, the whole thing to the power T. So this means that 15 over 9 is equal to root 50 over, 20 over 3, this guy to the power T. So that T is going to be the log of base root 20 over 3, 15 over 9. Yeah, so this is about T, and we'll put it in X. Okay, now we go back. No. When dealing with the decay, the only thing where you need to convert, it's not a must that you must always convert into grams, or anything can decay. In kgs, there's decay. The one that you convert is the one that is 250 grams of element left when you're given the initial in kgs. So you convert the grams to kgs so that you can use the initial kgs. So here you have 1 is equal to 2 as the initial, then E, then negative K. So we'll start by writing T so that we write the ln of 3 over 4 to the power 1 over 7 to 50. Like that. So that this can be reduced. If you divide by 2, you divide by 2, then you have half is equal to, when you push the T up, that whole thing becomes 1. So you get 3 over 4 to the power T over 7250. Then you can apply the and say, okay, so T over 7 to 15 is equal to the log base 3 over 4, 1 over 2. So if you multiply, so t is going to be 7250, and then the log 3 over 4 half. Then how long will it take until there is 250 grams? That's where now you convert 250 grams, you convert to kgs. So we get 0.25 is equal to, we're still looking for time, so you have to the initial, and then e to the power t of the whole thing here, 3 over 4, 1 over 7 to 50. Now, then you're solving t. So the only change we are doing in this one is here where there was half. Now we'll put 0.25 over 2. So to be the same thing. So you get t is equal to 7 to 15. And then the log of 3 over 4. After you calculate 0.25 over 2. That's what is going to be the time. So this video will be cutting soon. So when it cuts soon, we can look at your screenshots nicely. Try and see if you understand anything there. And then maybe we can end here. I wanted to introduce binomial, but I think I don't have much energy to finish binomial within this coming session. So we won't just start it. I want to start and finish it. So the next session becomes for tutorial sheet. So it will be done in the next session. You have a good evening.
Thank you, sir.
Thank you, sir.